Good morning, everyone, and thanks for coming. My name is Ling Xian from Catalyst, and this is my colleague, Fei Long. And for those who haven't heard about us, Catalyst is a New Zealand-owned company. We have a lot of talented people specialized in designing, implementing, and supporting enterprise-grade services and products using open source technologies. And Catalyst Cloud is OpenStack based public cloud in New Zealand. And both Fei Long and I have been contributing to OpenStack for a long time, for several years. And Fei Long is also the PTL of Zarker, which is a cloud messaging service in OpenStack. And myself is one of the co-reviewers of Mistral, which is a workflow as a service in OpenStack. But today, what we're gonna introduce you is another new service in OpenStack. It provides function as a service, or serverless. Its name is Qinling. I will introduce later. So first, we will talk about what is serverless, its characteristics, use cases, and then I will introduce Qinling, the functional service in OpenStack. And in the end, we will show you two interesting demos for how Qinling works, for how Qinling can be integrated with other OpenStack services. So because serverless is just a new stuff, appears in recent year, so there's no standard definition yet. But I always refer to Wikipedia for the common understanding of serverless by most people. So the name serverless is just used because the server management and capacity planning decisions are completely hidden from developers. So the developers who are using serverless architecture style are not responsible for managing or provisioning physical servers, virtual machines, or even containers. It's just managed by the cloud, a vendor-supplied cloud solution. So in most cases, when people say serverless, they usually mean function as service, right? So how function service or serverless can bring values to your business? Let's just take a very simple example. So suppose you are a developer and you are going to implement a web service application for your e-commerce business, right? So usually such application always consists of 3 layers: the website or mobile app, the API service, and database. So it's not necessarily to consider everything on day one, right? Because we just want to create an available application and make it online as soon as possible. So over time, maybe there are more and more customers visiting your website, especially during public holiday, for example, Christmas. So you may receive tens of thousands of requests per hour, which may lead to the high load to your API nodes. So now it's time to revisit the whole architecture and make some changes, right? So maybe the first thing in your mind is to add more API nodes. And what's more, you also need a load balancer configured at the front end. So which means you need to go through the hardware purchase procedure, the deployment, the initialization of the operating system, the configuration, and so on, right? You need a lot of work to do. But what would happen after Christmas? So you may not have the same number of customers visiting your website. So you may find most of the API nodes are always idle, doing nothing. So you may also want to decrease the API nodes and reconfigure the load balancer, right? Which means you still need a lot of work to do. But with serverless or function as a service, things will be clear. So imagine that after you finish coding and upload to the service provider, you could get highly available, scalable and production-ready applications up and running out of the box, which is amazing, right? But if we look back, I think maybe some of you want to remind me that it should be very easy to implement the same architecture using some existing cloud service, like AWS auto-scaling service, right? So in that case, the API node will be virtual machines. And they can be added or destroyed automatically by auto-scaling service according to some metrics you defined, right? But besides auto-scaling service, I believe you also need an ELB service, right? The elastic load balancing. So using an extra service means you get more money charged, right? And you also need to take care of the initialization and configuration of the virtual machines before you putting them behind the load balancer. And you also need to take care of the your whole monitoring solutions, the log strategy, and so on. But with the function service, you only need to focus on the code and leave everything to the service provider, right? So let's try to summarize the serverless characteristics according to our simple example. So first, as I mentioned before, you don't need to care about either physical servers, virtual machines, or containers, right? And with serverless, what you operate or manage is just your small piece of code. It's not your whole application. I think that's one of the most significant difference between serverless and platform as service, right? And also, with serverless, you actually have a lot of professional cloud engineers working for you to guarantee the availability and scalability of your functions, right? And stateless, lightweight. So strictly speaking, a function can have a long execution time, but most of the existing function service provider will limit the execution time in order for the customers to get significant financial advantage. Event-driven style. So the serverless can fit into the event-driven behavior very well. So when some events occurs or is dispatched, the function can be started instantly and only run for needed time. And most importantly, you only need to pay the money when the function is running. So there are a lot of use cases around serverless. So the first thing in my mind is cron job, because that's also a requirement from our own team. Because as public cloud provider, we have a bunch of periodic tasks running internally. For example, we have a script to check the resource usage of our cloud and notify customers so they can decide if they should increase the quota or just keep it as is. And we also have the task to check the expiry date of the credit card configured by customer in order to pay their monthly invoice. We have a lot of the similar tasks. So at the very beginning, when a developer finished coding, he just simply ran the task on his local workstation. All right. So gradually, as we have developed many scripts, we found they are running everywhere in different places. It's very hard to maintain, right? And it's not a good idea to just deploy a dedicated physical server or create a virtual machine and to give overhead to our operators just for that purpose. So in this case, if we have functional service, we have a single place. We have a dedicated place to run all the tasks. And we don't need to care about the availability and the consistency, right? And apparently, the serverless can be an implementation of Microsoft architecture. Right? They have a lot in common. And data processing and some follow-up actions. So if you are familiar with AWS Lambda, you will remember there is a typical use case for how to use Lambda together with S3, right? So when an end user uploads a photo, and he will see the photo thumbnail in another bucket in S3 after a few seconds. And we will show you a similar demo later on. And IoT. So basically, the serverless and IoT have a lot in common. So both are emerging technology that are introducing fundamentally new ways of managing networks. So as a result, they are requiring new ideas around design and deployment of applications. And IoT also helps traditional industries into data-driven paradigm, so which is what serverless is very good at. And also some other use cases like mobile backends and chatbots. So currently, there are already some existing solutions. The AWS, the Azure, Microsoft Azure Cloud, and Google Cloud, they all provide function service solutions. So their function service can be integrated with their own cloud services. So the function can be triggered automatically by their internal cloud notifications or events. And the customer can get more benefits if they are already using their other cloud services, right? So besides the three giants, a lot of innovation is still going on in this area. And things are rapidly improving and changing. So you can easily find the open source projects or commercial products in the market. For example, the OpenWhisk from IBM, the Fission from Platform 9, and Oracle functions, which was announced several weeks ago, I think. And most of the solutions are implemented using container technology. And some of them are even using container orchestration tool like Kubernetes or Swarm, right? But if you look at the list, you will find such service is missing in OpenStack. And of course, you can implement such service using the existing solution, open source solution. But that means a lot of complexity and adaptation, or even the risk of vendor lock-in, right? So that's one of the reasons I created Qinling, the functional service in OpenStack. And the other reason is when I playing with Mistral, when I was introducing Mistral to our customers, we realized that the functionality of Mistral is a little limited without the capability of supporting the customer's own function, their own code. It's not in the scope of Mistral. So that's another reason we need Qinling. We need functional service in OpenStack. And the name Qinling, the name has no special meaning. It's in real world, Qinling is mountains located in southern Shanxi province of China. And I use Qinling just because I miss China, I miss Shanxi, my hometown, after I immigrated to New Zealand 1 year ago. So just like other OpenStack services, Qinling use Keystone for authentication. It can provide dashboard to end users, and it uses a messaging system for communication between its internal components. It can store and retrieve data from database. It's all the same. What's more, in order to run the functions, Qinling also use containers. So by default, it uses Kubernetes as backend. But it could be very easy to add other options, like you can use Swarm, you can use Mesos, or even you can use Zun service in OpenStack. So Zun is a container management service in OpenStack. And the architecture of Qinling is very simple. It only consists of two components, the Qinling API and the Qinling engine. And you can talk to Qinling using directly HTTP API or command line interface, or even dashboard in future. And the Qinling engine is responsible for maintaining the mapping between function and containers. So you can see here, I put old and Docker services here because Qinling can be very powerful when it's used together with those two services. So old is alarming service in OpenStack. It provides the capability of trigger actions according to the defined rules against metrics collected by Slometer or Norky. And Docker, as I mentioned, is a cloud messaging service that you can use in your cloud application. There are already a lot of interesting and useful features in Qinling. So basically, there are 4 resource models: the runtime, function, execution, and job. So before you create a function, you need to have an available runtime that you can specify. And when a function is invoked, it's an execution. And if you want to run the function periodically, you can create a job. And most importantly, Qinling can be integrated very well with other OpenStack services. So besides old and Docker, for example, you can store your function in Swift, and you can specify the container name and object name when you create function. And also, if you want to talk to other OpenStack services in your function, it's very easy. You don't need to provide your tokens, your username, your password for the security reasons, right? You only need to use a predefined parameter by Qinling. And besides the code file and Swift object, you can even use your own Docker image to run the function, which means you can use your preferred any programming language as you like. And also, Qinling supports 3 execution styles. It supports synchronized function, asynchronous function, periodic function. Additionally, Qinling can support scale up or scale down the function according to the amount of requests that your function received, right? Which means you don't need to care about when your function can be, for example, the example I mentioned just now, the Christmas, the public holiday, when there are huge requests to your function. And finally, we provide a unified OpenStack command line interface to talk to the service. Right. Okay, so now I will show you 2 demos. The first one is a similar demo to AWS Lambda. So the left photos show you the steps of how you use Lambda together with S3. So the user needs to create a function in Lambda and create buckets in S3, and also need to create the notification configuration on the bucket. And after that, the user will upload photo, and after a few seconds, he will see the thumbnail in another bucket. So in OpenStack world, the steps are very similar. You need to create function in Qinling. You need to create alarm in old. You say, hey, if you receive some notification from Swift, please invoke the Qinling function. And then the user just upload photos to Swift. He will see the thumbnail. Okay, now.
It's a live demo, so please expect surprise.
No, it shouldn't be. So to save your time, I just record some comments here, but I will describe. So first need, is the font clear enough? Good? Cool. So first, in the demo tenant, we will see there is an available Python runtime we can use to create function. So I have a function here. Create. So you can see the function is very simple. The first step is to get a Swift connection, right? So you can see I didn't provide username, my tokens. I just use a predefined parameter context to get an available session of myself. And then I will download the original photo from a container, and I will resize. After that, I will upload the photo to another container, right? Very simple. So now let's create the function using the file. So I need runtime. Oh, sorry. Yeah, I need runtime, and I specify the function name and the entry. The entry means which module and which method. And finally, I need the code file, right? Okay, now we have a function, and we can take a look if the function has execution or not. Okay, nothing. And then I will create an alarm in old. So I need to specify the alarm name, and it's an event type alarm. So if it receives the notification from Swift, it will trigger our function. And we need the alarm be infinite, right? Okay, now we have an alarm, and I will go to the dashboard. Okay, we go to the container page. So there's no container yet. We need to create some necessary containers. For example, container name is Lingxian. And we need to create another container to, in order to put all the thumbnail. Okay, now we have 2 containers. And what we do is upload photos. Right? We will upload, yeah, it's not small picture. So we use this one. Okay. So we need to refresh maybe. No. Oh, no, still no. We will check if there are some executions for this function. Yes, here. Okay. Yeah, finally. Okay. So why it's a little bit slow, I need to explain. So there is a concept called cold start, right? If you are familiar with Lambda enough, you will know a cold start. Because when your function is invoked for the first time, under the hood, there will be a container that should be created to run your function, right? And if your function is running and it is invoked for several times, it will be very quick. But for the first time, the container needs to be created. So that's why it's a little bit slow. Okay, so we will see the original function, the size is more than 40 kilobytes, and you can see the size here. It's pretty small. And if we download the object and take a look, oh, it's here. Yeah, there. It's just a very small image. Okay, so now we will take a look at what happened behind. So just now we can see there is already an execution that was triggered automatically by old, right? And you can see the duration of the function, and the function just has no output. And we can also check the alarm history. Here. So we need to specify the alarm ID. Oh, it's not very easy to read. Okay, so you can see the first is, the first alarm is our creation action. So this alarm called the state transition, it will tell you which event triggers the function and the event type. We can see it's an object upload event. And we can also check the function output. Here, we just need to use the execution ID. Where is it? Okay. So you can see start execution and download the objects from the container and resize and upload again. Right. So it's just a very similar scenario to the Lambda and the S3. So, okay, so the next demo will be shown by Philong. Okay, so how to use Docker with Qinling.
So what I'm going to demo is how Docker can integrate with Qinling. Because as Lingxian mentioned in previous page, there are two very special characteristics about serverless. Is your function is stateless, and generally for most of the case is event trigger. So for Docker can be perfect to meet the two areas. For Docker is a messaging and notification service in OpenStack world. And how Docker can work with Qinling in this demo, we would like to communicate between functions to decouple your function. Because for general case, you could have many functions, and you definitely need some middleware, like either database or service queue. Queue service to communicate between one function to another one. So the next demo I'm going to show is we would like to use one function to monitor your service, another service like a website or a REST API, something like that. And when the function monitors the service, if the monitor there is, for example, a file handler error, the function will send a message to a queue. And then Docker will get that message and trigger another function, and that function will send a message to the maybe your operators. So it's generally like a pager. So I'm going to create the first function. The first function will try to monitor a service. So for here, we are using a mock HTTP service. I can show you the code. So you can just take a look at the check and trigger. It will access your website, and if there is a file handler error, the function will try to send a message to a Docker queue.
So disclosure, you can see the function is a little bit ugly here because the function will be run periodically by a job, and it will send text message to our phone. And in order to get less money charged, I just stop the function after 3.
Yeah, because we're just using a Trail account to receive the SMS. So Yeah, that's the idea. Okay, so this is the first function. The first function will monitor the, okay, I'm going to show the second one. The second function will try to send SMS to our phones. But actually, there is a problem. This morning, I just exchanged my phone with my wife's phone. So we have to recreate the key pair for the second one. So I'm not too sure if it could work or not, but finger crossed. Okay, so now we got two functions. I'm going to do next is, yeah. I need the second function ID because I would like to create a subscription in Docker for the particular queue. So the idea is when the function 1 send a message to the queue, Docker will forward, actually notify the second function. Okay, so now we got the subscription in Docker. The last one is we will create a periodic job to monitor, actually that will call the function 1 to monitor the fake service. It could take like
3 minutes.
1 or 3 minutes.
3 minutes.
Because the minimum intro in Qinling for a job is 1 minute. So it will try 3 times, so generally 3 minutes, I think. I think I got the question before we think about the demo to integrate Qinling and Docker from even Lingxian. Lingxian just asked, okay, Felong, why we do have to use Docker put in functions, integrated with Qinling? Because you can definitely merge the 2 functions into one, use a function to monitor your service, and then just call another API to send MS and whatever. So the idea is, I just mentioned before, for function as a service, for most of the case, you definitely need some middleware to link one function to another one. And you also need a trigger, an event, to trigger your function. So for Docker is a messaging service, and it is a notification service. So you can see in this demo, we are using the messaging service between, actually in the function 1. The function 1 will just check the fake HTTP service and send a message to Docker queue. And then Docker will use its function service, notification service to trigger another function, the function 2.
Yeah, I think there are some changes you need to do when you want to translate from the monolithic application to the serverless. Because you may have tens of thousands of functions defined, and you need some way to orchestrate all these functions. You need something like glue, right? So you need some services like Zakar or memory cache service or storage service to store the middle result, the middle output from some function to store some status. Because in serverless, I think most of the function should be stateless, right? You shouldn't store anything in the local.
Okay. I can't show you guys, but we have got
Me too.
the message.
Yeah. Yeah, it's successful. Okay.
Cool.
Yeah. So that's all. That's all we want to show you. So any questions?
Question?
Yes, basically, yes.
Can you coalesce related function into a container so that you know your resource allocation, or does Qinling provide you with some way of
Yeah, so
resource allocation?
the question, I want to make sure, you want to ask how I insert the function inside the containers?
Can you have like a end function to end container kind of mapping at this stage, or is it like one function is one container?
Yeah. So because the default backend is Kubernetes, so I just, under the hood, I will create a deployment in Kubernetes and with the runtime. For example, there are 3 pods in the deployment by default. And each pod is just running nothing. And when user create function and trigger that function using that runtime, there are some magic happen inside the one of the pod. The container inside the pod will fetch the function from Qinling service and just ready to run, right? And after you downloaded the function inside the container, and the container can be executed using the parameter you specified when you create execution. Yeah. So that's basically the underlying mechanism for how the function is running. Yeah. Yes?
Particularly because this is implemented on Kubernetes currently, did you consider using one of the existing functions of service and then building the OpenStack hooks triggers on that?
Sorry?
Did you consider using one of the existing functions of service layers and then putting your own OpenStack triggers and integrating?
So the question was, although by default I use Kubernetes, so can I just reuse some existing open source solutions and not only in OpenStack, right? Okay. So if there was a project called Picasso, I think. And the Picasso is implemented using Iron.io, the commercial company which sells serverless service. And they also provide an open source project, part of their commercial strategy, I think. And they just provide a very thinner layer using some RESTful API and call their own maybe Iron.io API. That's the way you mentioned. And I can definitely integrate with some existing open source solutions, maybe integrate with Fission, with Oracle functions. But there will be many layers. The logic will be very complex because they are something in the container ecosystem, in the container world. And I just want to make things easier and make it available in OpenStack. Right. So, for example, I need to integrate with Keystone, and I need to integrate with other OpenStack services. Because, the functional service is useless if it's just a separate service. For example, the AWS Lambda, if it's a separate service, it's useless. It's nothing. But if it's used together with other AWS services, it's powerful, right? Yeah. Yes?
Did we need to define some Docker image that can fetch the function and to run it? Did we need to do the job to?
Okay. So the question is, who creates the Docker image I used for creating runtime, right? So basically, as public cloud provider, it's the provider that will create some available image to create the runtime. Because in public cloud, we shouldn't allow, or basically we shouldn't allow the end user to upload their own image and run their own functions. Right, because there are some security issues. Because the image is defined by the end user and the function is defined by the end user, they can do something inside the container. Maybe they can, right? They can do bad things, right? Their function can do something to escalate from their container to the hypervisors, right? They will see other tenants' data. So for security reasons, as public cloud provider, we don't allow the end user to upload their own images. So we will provide images for the customer to create function. So basically, the runtime, runtime creation, runtime update can only be executed by the admin user. Yeah. But in private cloud, I think it's up to you. Yeah. Yes? No, it's not instance, it's container. And the container is created inside Kubernetes cluster, and the Kubernetes cluster is maintained, is operated by the cloud provider. It's not belong to some specific tenant. Yeah, but, okay, yes.
There's a few similarities with Storlets inside Swift.
Yep.
Which will build up a Docker container, which is a middleware into either the proxy or in the object store. I'm not saying they're the same, but I wonder if there's some integration you can do within Storlets, so Storlets can start using maybe some predefined containers or functions that you define in your stuff. So I wonder if there can be a bit more integration there.
Sorry, I didn't follow you.
So there's another OpenStack project called Storlets.
Oh, Storlets, right?
Yeah.
Okay.
So Storlets allow you to run code in Swift.
Yeah.
I'm not saying, I think that both can exist, they're both quite cool and do different things, but I wonder if there's some kind of integration we can do. So Storlets can then start using your, instead of having to always define or upload code to Swift to run in its Docker, what Storlets use, if we can go and integrate and call directly out to your product.
Yeah, it's likely that we can be integrated with Storlets. And because I'm not very familiar with the project, but what I know is Storlets just let you to execute your code, and the code is just your objects stored in Swift, right? So basically, you can just invoke the Qinling function in Storlets, and the Qinling function can use the function defined in the object. Definitely, yes. Yeah. Okay. Time is up. Thank you. Thanks, everyone.